Hello there, and in this video we're going to continue our look at adding and subtracting fractions, or what we like to call rational expressions. But this time we'll focus on the expressions when they have different denominators. And remember that with numerical fractions, like these first two listed here, we need to find a common denominator. So that's going to extend to regular expressions. So let's just take a look at how to do these two. 8/9 minus 1/2. So we need what's called the least common denominator, or the LCM, the least common multiple between the denominators 9 and 2, which means what is the smallest number that 9 and 2 both divide into at the same time. And just by luck, it is 9 times 2, which is 18. So we need, in order to be able to combine these fractions, we need both of the denominators to be written as 18. And remember, we look at it that way because we can easily multiply any fraction by a version of 1, or a fancy one, so that we can make the desired denominator. So in the first fraction over here, I'm going to go to red here. In the first fraction, we're going to multiply by 2 over 2. And that's going to give us 16 over 18. And in the second fraction, we're going to multiply by 9 over 9. So it's going to give us 9 over 18. And now we're off and running. We can now combine the fractions just like we did in the last video. 16 minus 9 is 7. So the final answer is 7 over 18. There we go. Now looking at the one on the right, it's a little bit different because while you can just multiply the denominators together to get a common denominator, you often can get away with a smaller number if you notice that the denominators share a common factor. Now something to notice here is that 5 goes into 10. So in order to get a common denominator, which is 10, we can multiply the first fraction by 2 over 2, and we end up with 6 over 10 plus 3 over 10, and that gives us 9 over 10. And there's our simplified answer. So how does this affect our work when we have variable denominators? And the key is always going to be factoring, which is why factoring is so important. One of the many reasons that factoring is pretty important. So let's take a look at this one on the bottom left here. 3 over x minus 4 over x plus 2. I'm just going to draw a line here so we know that we're in the bottom half of this now. So x and x plus 2 do not share any common factors. So using the same idea, we're going to say that the LCD is x times x plus 2. So that means my fancy one for the first fraction is x plus 2 over x plus 2. And you notice I'm going to put that in parentheses because it is a larger expression that's going to get multiplied by something. And in the second fraction, I'm going to put the x plus 2 in parentheses just for emphasis. We're going to multiply by x over x because now the fractions have the same denominator. Now remember, x plus 2 times x is the same as x times x plus 2. Actually, I'm going to write this. I'm going to write out another step before I go there. So this is equal to 3 times x plus 2 over, I'm going to write the x first, x plus 2, minus 4x over x times x plus 2. Now remember why you did everything. It is very tempting at this point to cancel out the common factors, but remember that the reason why we wrote it this way was so that we could combine the fractions. So I'm going to write this as 3x plus 6 over x times x plus 2 minus 4x over x times x plus 2. And now we can combine the numerators just like we did before. I'm going to need another line here. And combine like terms, 3x minus 4x is negative 1x, or just negative x, plus 6 all over x times x plus 2. And we're actually going to call that the final answer. Now, some things to note. Notice that the x in the numerator does not cancel with anything in the denominator. It is a term of another expression. It is not a factor, so we can only cancel common factors. The other thing you might be looking at is the denominator. Can we multiply the denominator out? Of course you can. It's just that in this case, when we're talking about rational expressions, we want to make sure that our answer is in simplest form. So it is better to leave it in factored form. And a simplified expression can be thought of in two ways. You can either have it all the way multiplied out, expanded form, looking like a polynomial or something, or it can be completely factored. So since we have that extra security of knowing that we have the simplest answer by leaving it in factored form, we just leave it in factored form. No need to go further. You can if you want to. Your math teacher might be impressed, but there really is no need to do that. Okay, so let's look at the one on the right here. Now, looking at those denominators, I do notice something a little different about this one. Notice that this second denominator, I can factor out a 2. Oops, except that's not 2 times x plus 4. That's 2 times x plus 2. There we go. So you notice that the denominators have a common factor with each other. So I'm going to just rewrite this to make it a little more clear. 5 over x plus 2 plus 7 over 2 times x plus 2. So to get a common denominator, again, going back to the red here, my fancy one here is going to be multiplying the first fraction only by 2 over 2, because now we have the same denominator. So let's see how this plays out. We have 10 over 2 times x plus 2 plus 7 over 2 times x plus 2. And when we combine, remember we keep the denominators the same. That's 2 times x plus 2. 10 plus 7 is 17. And once again, that is in simplest form. So there is a short intro to adding and subtracting fractions. Last video we saw like denominators. This video we see unlike denominators. Thanks for watching.